All right, so we are going to switch gears a little bit. Um, I want to make sure that, again, even though we're only doing new material through the 22nd, um, we still want to make sure that you guys have information that will prepare you for pre-calc next year. So one of the things that we would typically do is move into the next chapter, which would be right triangle trigonometry, um, eventually identities with trig functions. So a lot of times years ago, you would hear classes that were in high school. It wasn't pre-calc; they called it trig. And so that was one of the classes I took was actually called Trig, and it was all of these properties and identities and how the right triangle worked and so on and so forth. So you guys started a lot of this last year in geometry, and I want to make sure that we go over that basic stuff just today. So today should be what feels like a lot of review. So it should be pretty easy. That way you're still able to concentrate on doing your other work from the geometric and arithmetic series and sequence papers and quizzes. So I do know that there are a few of you, at least as of yesterday afternoon, who had finished the quizzes, and I got at least those scores back to you. It's not in the grade book yet because I didn't want people freaking out because they're not technically due till Friday. But at least I was able to email you back your scores and information. I have not checked today, so I've been in a meeting this morning, so I haven't had a chance. But just know that you still have time to get all of your stuff in. I also had a couple emails about late work. Please understand, there are benchmarks that I try to give you, and I know I keep using that term. I haven't figured out a better one yet, that you should be doing your work by, but that does not mean that it is absolutely positively you will have a 0 in the grade book if it's not turned in. You have the opportunity to turn all of that material in pretty much through the end of the quarter. But the reason I'm giving us these due dates is so that we don't let too much pile on. If for some reason you don't have the opportunity to finish it by those benchmark due dates, get it in when you can get it in. Just don't let it pile up. So for those of us that keep emailing me about late work, again, I understand something may be late according to the date I put in classroom, but you have the opportunity to turn things in at all times. So keep working on the assignments that I've already given you. Today, we are just going to take notes and go from there. So first thing that we're going to start with is our right triangle. I want to make sure that we are working on our definitions. And when we deal with our trig information or anything with our right triangle, a couple things that we need to make sure we remember is always opposite our right angle is our hypotenuse. And that guy will always be the hypotenuse. Now, depending upon what angle we're talking about, adjusts the perspective of where we're looking. So for instance, if I'm up here at angle A, and a lot of you remember even when I did this last year, I always circled the angle, kind of helped. Our opposite is the segment that doesn't have A in the name, so segment BC is opposite angle A, and we call the side that makes the angle with the hypotenuse the adjacent side. Now, if we're at a different angle, the perspective changes, and we're then going to change what is opposite and what is adjacent. So if I'm down here at angle C, the side opposite it would be AB. Again, segment AB doesn't have the letter C in it, shows us that it's opposite. The side that creates the angle intersects to create the angle with the hypotenuse is adjacent. Now, those are the only two that change because our hypotenuse will always be the longest side. It's always opposite the right angle. One of the things when we go back and we think about what we did last year, when these change, it allows us to keep the same length where it's supposed to be and the same angle measures where they're supposed to be. So first thing we need to make sure is we know what opposites and adjacents are. The next thing that we have to remember is that we should have memorized our basic trig functions. Now, we know that we have sine, and some of us may remember the Greek letter theta. Theta is just an angle, so I could have called it angle A, I could have called it angle C, or I could put a theta, that Greek letter theta, floating there. And our definition for sine is opposite over hypotenuse. Our definition for our next trig ratio, cosine, is adjacent over hypotenuse. And our last trig function is tangent, which is opposite over adjacent. And I know many of you remember that I get that on our calculators we've looked at these buttons a ton of times. And many of you last year would look at these buttons and it was sin, cos, and tan. Huge teacher pet peeve right there. Sine, cosine, and tangent, those are abbreviations. So for right now, we're not really going to worry too much about our calculator. Just know that these are abbreviations for the words sine, cosine, and tangent. What is different this year is we have what are called reciprocal functions. And we not only have our normal sine, cosine, and tangent, we have our reciprocals, which is cosecant theta. And I'll write this out later, but cosecant is actually the reciprocal of sine, which means now hypotenuse is on top and opposite is on the bottom. We have our reciprocal of cosine, which is secant. And it would look like this. But again, it's a reciprocal ratio. Oops. I knew I was going to do that. Dagnabbit. Hypotenuse over adjacent. That's why you use pencils. Hypotenuse over adjacent. And our last one is cotangent, which is our reciprocal for tangent, and that is adjacent over opposite. I was one step ahead. So last year we only concentrated on the first three. This year we're looking at all 6 ratios. So again, when we look at what these mean, the CSC is called cosecant. The SEC is not a division in college sports. Secant. And cotangent. So those are the reciprocal functions for our sine, cosine, and tangent. So one thing that we have to be able to do when we're using these, and some of you remember going outside, measuring how tall the trees were, how tall the building was, knowing that our trig functions are going to make it capable for us to find lengths as well as angle measures, we have to remember that we have to set up ratios in order to do that. So one quick example is if we're looking for the 6 trig ratios for theta. And that's it. We're not looking to do any solving. We don't care what that angle measure is. We just want to know, can we write the ratios? So in doing so, easiest is to write your opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent first. So notice our sine, cosine, and tangent. So up here at theta, we have our opposite side here. We have our adjacent and the hypotenuse. So if you still have to label, absolutely label. And we would have 8 over 17, 15 over 17, and 8 over 15. And each of those match these definitions up here. Now, some of you may, and I'm doing this as I'm writing them down, you can remember that we had our mnemonic device, SOHCAHTOA. Don't forget that you can still use SOHCAHTOA if you need to remember what the definitions are, and then you can keep that kind of floating around there so that you don't make the mistakes. So now that you know what those are, you can write the reciprocals for the other ones. So now we have cosecant. Notice I line it up just to keep it organized with our sine, because they're, again, reciprocals. And this one is just 17 over 8. Secant theta is 17 over 15. And tangent theta is 15 over 8. So right away, the very first thing that we do is we just practice those ratios. So that's honestly all we're going to do with that problem. Getting just comfortable with having those memorized. Now, the same question can be asked in a very similar manner, except without actually the triangle being given. So we want, what? I know. I will give it to you when it's your time. Apologies. So if cosine, let's call this one B, is, let's go 6 over 11. Find the other 5 trig ratios for triangle E, A, B. All right, so that's all the question's going to say. And we then would have to create probably our own triangle so that we have a visual of what this is supposed to look like. And then after you create your own triangle, make sure you don't put angle B as the right angle. And it doesn't really matter what your triangle looks like. You just need it as a visual. A is going to be in the middle. It doesn't tell us what the hypotenuse is. It doesn't tell us what the right angle is. So we have to remember that if we've named it appropriately, A is the right angle. And it really doesn't matter where E or B go. We just have to make sure that those are, we have to remember that those are our acute angles. And so those are the ones we're allowed to deal with our trig ratios. So what is important is that this guy tells me what my side lengths are supposed to be. So with cosine B as 6 over 11, I have to remember that the definition of cosine is adjacent over hypotenuse. So if I'm up here at B, and I know that this is the hypotenuse always, opposite is the segment that doesn't use B as one of the endpoints, and our adjacent is here. That means this side is 6, and this side is 11. And I have to use the Pythagorean theorem to find EA. So EA squared plus 6 squared equals 11 squared. And we end up with ending up subtracting 36 from 121. So EA squared would end up being 85. And I have to take the square root of both sides, so the length of EA is the square root of 85. And just to make sure, 85 divided by 5 is 17, and the only way to make 85 is with 2 prime numbers, so there's no way to simplify that. So I'm going to leave this as the square root of 85. It is simplified, and we have worked way too hard this year to do decimals. We know that we want exact values. So with that being said, we're now going to be able to do our the other 5. So sine B, I almost put theta again, is opposite, so radical 85 over hypotenuse. We already have cosine. I'm going to write that down just to kind of keep things organized. And tangent, TOA, I did it again, is going to be opposite over adjacent. So we're lucky there. The radical 85 is in our numerator. Adjacent is 6. Now we do our reciprocal functions. So cosecant of angle B is our reciprocal, which means now 11's on top and radical 85 is on the bottom. You cannot leave the radical in the denominator, so we have to rationalize, which now it comes in handy if you remember the pattern that the radical shows up on top, just the radicand, so the number inside on the bottom. And this is your simplified ratio, not that. So that's the final answer that we would want. Secant of angle B is 11 over 6. And cotangent of angle B is 6 over radical 85. But again, we have to rationalize, and that means eventually it will look like that. So what we're looking at is, again, trying to draw on a little bit of our geometry knowledge. We start with what they gave us and remembering what our fraction's supposed to be, labeling it around a triangle that we have to draw, and then making sure that with the Pythagorean theorem, we solve. Now, would it have been nice if that came out to be something a little bit nicer than a radical? Absolutely. But nothing's any different than what we've worked with all year. So that's the same type of problem that we had in our first example, just had to do a little bit of work to get there. The last thing, I know I said I'm going to try to keep this short because I'd rather us spend time finishing, but also kind of getting a little bit of a review of what we've done in the past. The last example that I want to show you does bring back some of our information from geometry, and that's with our special right triangles. I am certain that you remember that we had 30, 60, 90, and we had our right isosceles triangles where we had our 45, 45, 90. And in each of these, we had said that there was formulas that would appear around each of our triangles in order to memorize them. We had a ratio of our sides that always came out when it was this type of triangle, and only these two. Opposite our 30-degree angle was always one of something, so a lot of times we called it A. Opposite our 60-degree angle was always that value times radical 3. And opposite our 90 was 2A. And that was how it was with all of our 30, 60, 90s. Our right isosceles, we knew that each of the legs had to be congruent. And then opposite our 90-degree angle would be some value times radical 2. So these were the two formulas that we did a lot of work with. Some of you may remember them, some of you may not. If for some reason you're having trouble, we can always review that, but you could also go into my YouTube channel and find that I've done special right triangles with the geometry class just last week. So we did a lot of examples over these two types of triangles. If you're still having issues, you can go back and watch some of those or look at the notes. And fast forward through whatever you need. The good part here, though, is that because whatever this value is, when I look at my fractions, that common factor of A, so whether this was 3, 3 radical 3 and 6, or 5, 5 radical 3 and 10, that common factor divides away with that ratio. So it's nice when we look at this as the ratio of 1 to radical 3 to 2. And over here is that 1 to 1 to radical 2. So if we were to ask us to do our trig ratios that go with this, in this first one, if I wanted to do sine 30, my opposite is 1A, my hypotenuse is 2A. Again, you can see how that common factor is going to cancel out. So sine 30 will always be a half. And if you go into your calculator, as long as it is in degree mode, we saw that DRG changes it. But if we put this in degree mode and did sine 30, it's 1/2. So it'll always reduce to 1/2 because of that ratio. If I did cosine 30, it's adjacent over hypotenuse, and that comes out to be radical 3/2. And if I did tangent 30, that's opposite over adjacent, so that's A over A radical 3. And you can see that that radical 3 shows up in the denominator, which again means we're going to have to worry about rationalizing, and that radical 3 is now on top with just the radicand underneath. So we end up with radical 3/3. Now that's just the 3 basic ratios. If I wanted to keep going and do cosecant 30, I'm going to take the reciprocal, and now that's 2/1. If I want secant 30, I need to take the reciprocal of this, and now that's 2 over radical 3, which is 2 radical 3/3. And the reciprocal of tangent is again our cotangent 30. Well, the nice part is that's going to be radical 3/1, or just radical 3. Now that's just the 30-degree angle. If I did all 6 for the 60-degree angle, I'd end up doing the same process, just making sure that I switched my opposite, adjacent, and hypotenuse. The nice part for our 45, 45, 90 is you'll see a lot of repetition because there's only one real angle to worry about. So if I did sine of 45, that's going to be opposite over hypotenuse. So that's 1 over radical 2. And when we rationalize, we get radical 2/2. When you look at what's going to happen with cosine, it's the same thing. That 1 over radical 2, so it's radical 2/2. And tangent, good gravy, is A over A, opposite over adjacent. So when we do the reciprocals, cosecant of 45 is the reciprocal of sine. Well, that's going to just be radical 2/1. Secant, which is our reciprocal of cosine, it's going to be the same thing, radical 2/1. And cotangent of 45 is the reciprocal of A over A, so we're right back to 1. Just a little reminder, we can do all with the 60-degree angle as well. So that's all I want today. What I'm going to ask is I'm going to give you kind of a couple examples just to practice. It's not required. I'm not asking you to take pictures of it and send it in. I am just asking that if you want the extra practice, you can look at it just to kind of see where we're going. The other thing I'm going to suggest is that you do take a look at some of the old videos on special rights, if need be, that I have loaded already for the geometry classes. I will put the notes that I've just given the geometry classes on the introduction to the trig stuff. If you want to see anything different, it'll be loaded on your Google Classroom here after I'm done with honors geometry, and that'll kind of give you a little bit of a buffer if for some reason there's some things that you've forgotten. So no new homework, just going to be the notes with a couple example problems to practice, and that'll be it. And then on Friday, I will put in Google Classroom whether or not we're meeting and what time. So I am off to do honors geometry now. And if you have any questions, continue to email me and I will talk to you later. Have a great day, guys. It's sunny. It's actually already warm outside. So get outside, get some fresh air, smile. Have a good day, guys.